Hello, and welcome to another CIQ webcast. Good morning, good evening, good afternoon, wherever you are. We appreciate you spending the time and joining us. If you're new to us, welcome. We hope that you get something out of this. And if you're returning, as always, add questions as we go, and we welcome you back. Today, we're going to be talking more about Singularity and Apptainer, mainly Apptainer. We spent a lot of time on this, but I think it's going to be good that we dive in a little bit more and kind of learn the history of it and where it's come from, where it's going. So today we have Cedric, Ian, and Greg. Welcome.
Hi, everyone.
Hello.
Thanks for joining. So if you guys don't mind introducing yourself, Greg, as always, I think we know who you are. I'll let you go last. Cedric, tell us who you are and what you do here.
I'm Cedric Clerget. I'm software engineer at ControlIQ, and before that, I worked on the Singularity project, now Apptainer.
Very nice, thank you. Ian, you've been here before, but tell us about yourself again.
I'm also a software engineer at ControlIQ, and also I've worked on and am one of the maintainers of the Apptainer project.
Thank you. Greg?
Hi, I'm Greg. I'm excited to be here actually with Cedric and Ian because this represents, I think, the lion's share of most of the critical and feature development that has occurred over the life of the Singularity project. Really is us three. There are several more individuals. They've gone off and are doing different work in different organizations, but the lion's share of this work has been us three.
That's fantastic. It's exciting for us to be able to spend time with the three of you together. Before we go any further, Greg, I want to go ahead and tell you that if I suddenly disappear magically, I'm going to leave it to you for a while. We have thunderstorms, and I've got lightning within a mile of me, and my internet keeps flickering. So exciting times. So just
I
magically
cannot
go away.
I cannot replace you, man. No way. It's going to suck without you.
Not really. So first of all, I would like for you guys just to tell us a little bit about how long has Singularity been around, and kind of a follow-up to that, instead of stopping asking, and why was it created?
I could take that one on. So Singularity has been around for, oh my goodness, 5-ish plus years, maybe even close to 6 years now. It was created way back out of high-performance computing, or out of the high-performance computing necessity to bring in containers into the ecosystem. At this point, Docker was taking off and kind of revolutionizing containers in the rest of the ecosystem, and enterprise kind of focused workloads, microservices, and whatnot. And they did such a great job in terms of really just getting containers out there and making them just a piece of our core infrastructure, that researchers started to get wind of this, and researchers started to realize how important containers could be for a lot of what we're doing in high performance computing. But there was a little bit of a disconnect in terms of the architecture that we use for traditional high performance computing. We've been using a fairly flat and monolithic architecture called the Beowulf, where pretty much every HPC system has been built kind of on this same model, where users log in via SSH, they bring over their applications, they compile their applications, they test and optimize their applications, and they bring over their data. Then they work with the batch scheduling system. And this is a very manual process where people are physically, well, I guess technically they're not physically logged in, but they're actually like logged in over SSH, and they have shell accounts, and then they're going to be running jobs as themselves on these computers. And then the batch system will actually run the job across hundreds or thousands of compute nodes. And what we end up with is kind of an architecture where you have users, non-privileged users, running on these systems, kind of like we used to run decades ago. And that's the standard mode of operation in terms of how we operate with these HPC clusters. So Docker and the like at this point focused on, they had a daemon that would run, which would run the containers on behalf of the users or behalf of whoever wanted to run containers. But that was a daemon process, and that daemon process ran as a privileged user, ran as root. So for us to install Docker onto HPC, we would have to give users access to this root running daemon, and potentially give users the ability to manipulate and control that underlying cluster at the root level. And obviously, this is a no-go. Whenever users get access to anything that has privilege, we usually call that a security incident. So we basically had to figure out, how do we give users and researchers the ability to run containers in a way that aligns with a traditional HPC focused architecture. And I prototyped Singularity, and within the initial idea, going to the point where it just took off. I mean, it was within a year I started hearing about it being running on almost every major supercomputer that I knew of. And it just took off. And it took off because we solved such a big pain point in the industry in terms of, how do we support containers on these big HPC supercomputers. And from there, Cedric joined the project, Ian joined the project, as well as many other people out there in the community. And both Ian and Cedric, especially, but people much smarter than I, that were able to take this idea that I kind of put out there, and then be able to transform it into something that was that's just amazing. Just as an example of that, when I first wrote it, there was two versions that I kind of coined. Version 1, which was actually a little bit more like snaps, if you're familiar with snaps. Version 2 was a container subsystem written almost predominantly in C, with a little bit of shell code kind of around the outside of it. And that was predominantly written and maintained by me. We ended up having some external contributions from the community, and amazing contributions to make it more OCI friendly. So at that point, now we were able to coordinate and be more compatible with Docker. But several others, Cedric, for example, then was able to take that and rewrite it and re-implement it in a more security friendly way, in a more scalable way, in a more professional way, and rewrote it in Go. And version 3 was released. We introduced some additional things, and again, some additional pieces from other people in the community and other members of our organization, that we were able to bring in things like the Singularity image format and other things. But Cedric was responsible for pretty much architecting and building the entire application set of Singularity v3. So I look at the code, and it's so far beyond me right now. I can't even help. And it's so sad. I look at it and I'm like, I don't even know where to contribute code to. But it is a fantastic rewrite and reimplementation of the code. Ian took all of the pieces that I made out of the build architecture to build containers and whatnot. And Ian brought all that forward in terms of moving that into Go and rewriting all that, making that better, taking it out of shell, because I had most of that in shell, and actually writing that into Go and compiling that. So between the people you have here, you pretty much have the lion's share of the predominant remaining developers focusing on features and forward movement. There are more that definitely deserve mentioning. And I'm gonna bring out Dr. Dave Dykstra. I always call him Dr. Dave because that's it's either his Git or his Slack. And Dave, I'm sorry, I always forget, but I just always call you that. So Dr. Dave, who is a computer scientist at Fermi National Lab, and he has been part of the community since very early on, and been a tremendous member of the community. We have got Krishna Mariki, who's our release manager now, and as well as lots of people over the duration of the project that have really contributed and just made this project just amazing. Just to name drop a few more. Vanessa has been fantastic in terms of bringing in initial OCI, and Oh my goodness, I'm going to kick myself. And so in about 2 minutes, as soon as I hand the mic back over, all these names are going to flood back into my head. But yeah, anyway, I'm going to pass the mic back as I think I'm done blabbing.
No, that's fantastic. Thank you for sharing that. So whenever we talk about HPC, you start thinking about scale and how big these things can get. Those early versions of Singularity, what was the scale expected to be, and what did it get to?
Oh my goodness, some of the biggest supercomputers in the world. I mean, one of the biggest right now, Fugadu in Japan is running Singularity. By the way, I'm already having so Michael Bauer, Dave Trujan, Eduardo, Dave Godlove, Yannick. Oh, now they're all piling back in my head. But
There
these
you
are
go.
some of the previous kind of contributors that have been part of this project. But what's awesome is, if you go back and look, and I think the last time I looked at the contributors, even though I haven't touched it in like a couple of years now, I think I'm still the leading contributor to the project.
Yeah, I think it was just verified too. There you go. So what were some of the initial use cases for Singularity? I mean, I know we talk about everything was getting exciting around containers. People were starting to implementing containers, and CI/CD came along with making sure that it was easy to deploy code, easy to deploy applications. But what were some of those initial use cases in HPC that really demanded or drove that container conversation forward?
So I can jump in on this one. So for like the scientific community, the key here was actually reproducibility of scientific computations. So like scientists will develop a model and a set of applications essentially on one system, and then want to share that application with their colleagues that are working on potentially different systems that have different versions of operating systems installed, different tooling installed, and they want to be able to package up those applications and run them on a different system without worrying about what is typically called dependency hell, where they have to go and talk to administrators to figure out all of the dependencies that need to be installed by system administrators in order to run this application and verify the results of their colleagues. So that was kind of the core use case, I think, that were some of the first requests for containerization that you got, Greg. Is that correct? I think that was kind of the main driver for the initial investigation into building Singularity and just containerization in the HPC space, and looking at what the current options were and what was lacking in some of those options and what needed to be built in order to satisfy that need.
It's excellent. Thanks, sir.
There's been a desire to increase the diversity of workflows and job types supported by high performance computing systems for almost as long as I can remember. When we first got involved in high performance computing, when I was first doing it, I mean, HPC meant something very specific, very tightly coupled, MPI focused applications that were designed to scale massively large. And we created these gigantic systems to support those. But what do you do when those jobs are either waiting for other jobs or they're not fully utilized? You have a whole bunch of computing space. So we always wanted to backfill that computing space with other types of jobs. And, for the most part, I mean, a lot of people's jobs would fit on those systems. But as we saw the kind of the general population of what we anticipated as typical workflows, like typical users are like high energy physics, right? Computational, chemistry and all of these sorts of things. And then all of a sudden we saw political science wanted an account. We saw library services. The library wanted an account. And I mean, there was all of these kind of very different use cases, and so many of them just started saying, well, I don't want to run on on an older operating system, which is what the system's running on. I want to run on the latest Debian, or I want to run on the latest, whatever. And I have a container that I already made, and I just want to run inside that container. Why can't I use that container? And so there was a lot of effort and emphasis put on how do we better enable this, what we called at the time the long tail of science. And again, containers were incredibly valuable for that.
That's very cool. And I think, Ian, you have something to show us here a little bit about kind of that whole wanting something that's not necessarily there and being able to break out of that dependency hell. So that's cool. I hope I'm right. One of the other things I wanted to ask is, are there use cases outside of HPC that Apptainer is being used for today?
I could take that one if no one else. That's one of those cases where I was waiting to see if everyone else was going to anyone else was going to step forward, and instead, I think everyone
Every
took a
step
step
backwards.
back.
Yeah, they did.
We're seeing a lot of interesting workflows and use cases for Singularity and Apptainer. And by the way, we didn't really talk about kind of the relationship between Singularity and Apptainer at this point, but I'll see if Ian or Cedric wants to take that. But in terms of the use cases, it really is designed as a container solution for traditional HPC, and that's really its primary focus in terms of why it exists and whatnot. But this is, when we decided to move it into the Linux Foundation and rename it, which was a request by the Linux Foundation, we put it out to the community, but Apptainer ended up winning that name. And the reason why is because what we created is not an HPC specific solution. It is an application container solution. And I kind of make a very, distinct point between a service focused container, which is predominantly designed to run in the background, versus an application focused container, which is predominantly designed to run in the foreground. And it seems like a somewhat trivial split, but it's incredibly important. And so, for example, if you want to run a container system that you want to run an application that exists inside of a container, but that application is a graphical environment, that application is going to be working very closely with your underlying file system, your home directory, other resources like GPUs, FPGAs, InfiniBand. I mean, maybe direct access to file systems. All of a sudden, when you're thinking about the difference between a service-focused container versus an application-focused container, the application container actually has some kind of real interesting use cases that really you want to be thinking through. And Apptainer and Singularity are really designed for those sorts of applications rather than services. Can it do services? Sure, you could. Can Docker and other container systems do applications? Sure. But, one's designed predominantly for services and one's designed predominantly for applications. So in my mind, you want to use the right tool for the job in all cases. And, that's what Apptainer and Singularity are best for, applications.
That's very good. And I believe we do have a question. If we can pop up the question. There we go. So the question is really, are you going to change the format name from CIF to something else? AppIF, AIF. Is there a desire to change that?
I can take this one. So as a part of the migration from Singularity to Apptainer, we've made the decision to keep the same Singularity image format for the images built and used by Apptainer in its 1.0 version. The primary reason for this is because we understand that there's going to be a period of transition between people using older versions of Singularity and getting onto Apptainer as a new tool and a fresh install. So we want to make sure that we don't have Apptainer build containers that would not work on older versions of Singularity, specifically versions of 3.x Singularity. So we don't have any plans of making a Apptainer image format for the 1.0 version of Apptainer. And traditionally, this project will create a new major version when it does make a breaking change to the image format. So that would be something that would come out in potentially an Apptainer 2.0.
Thank you very much for the question, John. As always, welcome back, by the way. So we've talked about kind of what Apptainer is good at, but I think there's something that we've missed in this that we don't talk about. What are some of the things that Apptainer would be good at that maybe people aren't thinking about today, or that they're not using it for today that maybe they should be? Let anyone take that one that has an idea.
So there's a couple areas that due to the image format and the problem set that we set out to solve, we did certain things differently. with Singularity and now Apptainer than the rest of the container ecosystem. And one of those, as an example, is, and this is related to the question that just came up, which has to do with CIF, and that's the Singularity image format. Most container images that we're thinking about are usually in the format of what's called OCI. And OCI, Open Container Initiative, has a format which is a layered format of tarballs. And those tarballs are stitched together via metadata and a manifest. And we use this manifest to pull all the tarballs, all the layers of a particular container, and we assemble them all at runtime. So when somebody wants to run in a container, we first download all the layers, and then we assemble them, and then we run inside of that image. Now, Singularity, we had to approach this very differently because tarballs, for them to be used, have to be cached. And the last thing we wanted to do is, if we're running a job across 1,000 nodes, is cache all of the same data and then have to stitch all of those together from the same state directory. And it gets incredibly complicated at that point. So we wanted to do something that really is optimized specifically for the architecture of an HPC system, knowing that HPC systems are designed around kind of two facets. The first one is the compute requirements, and the second one is the file systems. And no matter what kind of a system you're building, whoever's architecting that system have to build a compatible and capable file system for whatever size system that they're creating. So it made a lot of sense to leverage this shared file system for the container images themselves, and then to be able to do some fancy trickery to allow that file system to actually be optimized for running on, some sort of parallel file system or shared file system. So the CIF format is a single file format, which is an actual file on disk. If I wanted to give the container to you, Zane, I would copy it to you. I can email it to you. I can FTP it to you, SCP it to you. I can put it up on a website. You can download it from there. I can put it in Google Drive, give you a link to it. I mean, there's no limitation in terms of how you move around these containers. Luckily, the OCI registry format now also has the ability to deal with blobs. So we can even use an OCI registry to actually move around these containers and share these containers. But because it's a single file, you download it, and you can look in your home directory and see, any number of single file based containers in there. As a matter of fact, we make them executable. They're modeled after the ELF binary format in Linux, and we've made some changes to it, of course. But each one of these files exists in your directory, and if you want to run one of those files, it doesn't, there's no splatting out of tarballs. There's no caching of data. It just runs. Zane and I was playing with Singularity just the other day, and Zane, if you don't mind me saying, you actually remarked on how remarkably fast Singularity is when you actually open up a container. It could be a big container. It could be hundreds of gigabytes if you want, and it's instant. The moment you run Singularity shell pointing at a container, boom, you're sitting in that shell. There's no waiting. There's no loading. There's no dealing with metadata or layers. It's just instant. Well, the reason why that's happening is because of that image format, and we're able to mount up that image format directly and then leverage that image format. And if we're doing this over parallel storage, it's incredibly efficient. We can actually do that very, very fast. So you can actually load up an application, and there's an example of this that I've used to talk about a lot, and I'll bring it up here. There's been several national labs and large sites that have basically said, okay, we want to run this Python MPI program across the whole system. If they do it just on their standard parallel file system like Lustre, there was a couple cases that said that it was taking nearly 30 minutes just to start the job, just to load up all of the data, all the Python bits, all the metadata operations. And to do that on Lustre is like a distributed denial of service attack on your metadata server. It's not fun. You have thousands of nodes all literally congesting your metadata server to the point where it literally takes 30-ish minutes. Well, if you put that into a Singularity container, that whole application, put it into a Singularity container, put that Singularity container on the exact same storage that you were launching that Python job from, it went down to 6 seconds. 30 minutes to 6 seconds. Massive, massive optimization. And that has to do with that image format. So the whole reason I'm telling you this whole story is because that image format is so important. And what we've approached it very differently than the rest of the community. So from that image format, we're able to think about things differently, like cryptographic signatures, signing that data, validating that data, building a trail of provenance around that data. And wherever you bring that single file container, there's no services, there's nothing you need to consider. It's all in the file, just like you sign an RPM, right? If you're going to build an RPM and distribute that for your operating system, and somebody does a DNF or a yum install of that RPM, it's like you want to have that signed, don't you? Well, why would you want anything different from the containers that you're running on? You want those signed. So we did that. We've actually had that working for, oh my goodness, 4-ish years now, maybe. It's been a while. And that's been kind of a really important piece of that. And there's also, we can do things like encryption. We can actually encrypt that container, and we never splat out the decrypted data. So again, lots of things that we've done different that give them really cool use cases. Like, what if you've now put that on an edge device that's in an insecure area, right? You can actually protect your data. So when it's, if somebody gets a hold of that edge device, well, the only thing they're going to see is an encrypted blob. They won't see your models. So a lot of kind of cool use cases around that. Ian, Cedric, anything I'm missing?
I think you covered it. You know the tool pretty well.
That's his way of saying, my goodness, I can't add anything else. He's talked so much.
No, we have a question again from Tron, and we have 2 questions from Tron. So in his previous question, he was asking not as much changing the file format or the extension, but actually just changing the name, like what we call an Apptainer container.
So like you can use any file extension you want, but the actual underlying thing that we're going to use, we're still going to call it CIF. And so it probably makes sense to still use .sif as a suffix if you want, or you can use .app or anything really. It's not relevant to the actual execution of the container.
Thank you, Ian. And
I think the question, real quick, was also a little bit about the project name CIF, because it is a sub project, and that format. We're still going to be calling it CIF. Ian, do you want to take that? Like, we're not going to change the name of CIF internally, or the sub project of CIF to like an AIF.
Yeah, that is correct.
Very good. Thanks again for the question, Tron. And this one's actually directly for Cedric. What is the most complex internal component or subsystem of Apptainer in your opinion?
I think this is regarding the mount system. With Singularity v2, we had multiple vulnerabilities, which where it was possible to exploit to gain privileges. And for v3, it has been reworked, and in a way where mounting is done asynchronously. And we need to I can tell it. Yeah, there is multiple steps involved to create the container and the mount down inside this container. So, yeah, this has been
very good.
The most complex part.
Thank you very much. All right, so Greg kind of touched on being able to cryptographically sign things. I think it's important to understand kind of the why, the how. Like, why does that matter to me? Why would I care if I could encrypt a container? Why would I care about where I encrypt a container? Why is that important? Or why is it different?
So I guess there's kind of 2 things there, right? There's also like the why would you care if you can sign a container, as kind of maybe a first thing to touch
Sure.
on. And so I think it's kind of interesting that we've had so much time with the container community where everyone's been using containers to manage and install applications, but nothing's been signed as a manner of how it's been distributed in general. Whereas when you compare that to like packaging systems like RPM, you really wouldn't trust an RPM that wasn't properly signed. It'd be a bit suspect to install that on like a production system. But that's how we've been working in the container community for a long time, and that's a gap that many projects have seen and want to like build standards that will allow everyone to use a common signing method. When Apptainer or Singularity was created, and when it was looking at doing cryptographic signatures, these things weren't in place in a way where we could integrate with those types of projects. And at this point, I don't see a clear project in the forefront that everyone is adopting that everyone can align to at this point. So what Apptainer has done is implemented a signing method as a part of that single image file where we can attach a PGP signature or a signature generated by PGP keys into that container file and use that to validate the contents of the file system that we mount for the container. So we can have the ability for someone to sign a container, do a key exchange out of band of the container transfer, and then have the person that receives the container verify that it came from the identity that they intended, and make sure there wasn't any corruption or man in the middle, essentially. So that's one thing that's a value add that's nice about the Singularity image format. Another thing kind of on the encryption side is it's nice to be able to have the kind of, protection of your data while it is in transit, and also potentially on other systems that you're executing on. So there are use cases where people want to protect things like AI models or machine learning models, like things that are kind of in the classification of intellectual property, that they're packaging inside of their containers that's core to their value adds, and they want to make sure that information is protected while it's in transit, and also potentially while it's on other systems that other users are able to access.
That's awesome. Thank you very much. So I think the next logical step in this is to ask, so with everything that's gone on and all the different changes that have taken place, so renaming or moving from Singularity to Apptainer, what's coming next, or what can people expect to see next out of Apptainer?
So there is steps for running fully unprivileged, and actually Dr. Dave has done some work in this direction. So to give a bit of context, Singularity Apptainer can run unprivileged since not the beginning, but since Linux kernel has supported user namespace, which allow to create a container environment. But the problem, if we want to support the CIF format, we need to extract the image onto the disk and execute the container from there. So the idea is to keep the CIF format and run the container from the CIF image directly. So Dr. Dave has implemented recently, and it should come in the next release, I think. So we could load CIF images with squash fuse, and he also added support for fuse overlay face to be able to write inside the container into a persistent layer. So yeah, that's the direction actually, and we will probably extend that by using the Linux kernel library So there was some work done in the past and some proof of concept done. It works pretty well, and we should be able to also support encryption also and fully unprivileged. So, but still some work to do on this front.
That's really exciting. I thought Greg was about to say something. Sorry.
No, I've talked a lot. I want to give everybody else a chance,
Yeah.
but this is running completely unprivileged while supporting SIF and all of the other features of Singularity and Apptainer is really amazing. Now we have supported unprivileged, fully rootless, actually since early V2 days. So for four-ish years. And we've done that through the user kernel namespace. But now being able to not only do, but there was a lot of features that we kind of, was not able to do properly when we ran in that unprivileged mode. Now being able to run in the fully unprivileged mode and still get access to all of those features. Now that is remarkable. That is very, very cool.
That is very cool. I think one of the other things that I've heard you guys talking about that's coming, and we've talked about it a little bit before, is just checkpoint restarts. I don't know, Ian, if you want to talk a little bit about what that is.
Yeah, so that's an integration with a project that's been, I think, around for a little bit in the HPC community, and some sites are very familiar with this project called DMTCP. And so the idea of this project is to allow checkpointing transparently when you're running your applications. And so we have created an integration with that technology in order to allow that to be injected into containers when they're running, so that you can checkpoint your containerized applications as well. So there's a couple of caveats to that, because it uses basically it gets in between your application and the shared objects that it links against in order to have hooks into your application and do its checkpointing. So you need to have dynamically linked applications in order to use this. But it does add some really interesting capabilities to systems that need to be able to interrupt jobs.
Yeah, that's very cool. I've had several conversations where there's a lot of excitement around that, being able to do that for a lot of different reasons. Very cool. I also see that Tron is heckling Greg. I love it, and welcome more of it. So Tron says he'll be encouraged to switch from Singularity to Apptainer if Greg can repeat Apptainer, not Singularity, 10 times without mistakes. And he said maybe he'll take 5.
Apptainer, not Singularity, 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 Apptainer, not Singularity.
Wow.
Whew.
Done. So it's time to start transitioning. Thank you. You have 10 seconds to comply. So I want to encourage you guys, if you have other questions, please start sending them in. I think we've kind of gotten to the end of what we wanted to talk about. We want to make sure we leave time to answer questions. I see that Justin just asked one. Are there plans to better integrate with CNCF projects like SigStore and Notary V2?
There are. So something we didn't talk about the move of Singularity to Apptainer is that the biggest spur for that move was the opportunity to join the Linux Foundation, which it puts us in the same kind of I guess project umbrella as many other container-based projects or container integrity-based projects. So a couple listed here are things like SigStore and Notary V2. So SigStore has like is a relatively mature project, and that's something that we could integrate with today without any technical issues, as far as I can tell from my evaluation. The key there is that you need to have your Singularity container stored within an OCI registry that supports OCI artifacts, and that's how you actually attach the signatures to your container images. You basically say you want to sign this container at this registry location, and it'll attach a signature to that container at that registry location by adding another artifact to a registry path that's named based off of the container you're intending to sign. So that's something that's very doable and something that we're looking at, as well as Notary V2 is something that is basically a project looking to make a better version of what is currently, I think it's called Notary. I'm not sure if it's called Docker Notary, but it's a container integrity system that came out of Docker, the company. But it hasn't built a lot of traction in terms of just the general open source community at this point. And so that's an initiative to build something very similar to that with I think slightly different properties than what SigStore provides in terms of your kind of like integrity model and how you like verify whether something is from a particular entity. But they're still in the discussion phase and building out prototypes. And they have, to my knowledge, there hasn't been something that has been set in stone as this is the path we're going to go down and what you need to do in order to integrate with us.
Great. Thank you very much for the question, Justin. So we have another question from George. Any changes with the move from Singularity to Apptainer?
So I can jump on this one again. So really the change is just that the application name is different, but we also supply a symlink with the name Singularity, so you can still use this your same like scripts or kind of commands if you're still sometimes mistype Singularity instead of Apptainer like Greg, and have all of your commands work. There are some changes to some of the default remote endpoints, like we store keys by default inside of OpenPGP's key server instead of where it was stored before, and things like that. But really the core use case and usage of Apptainer shouldn't feel any different than what you're familiar with Singularity. We also have taken effort to do things like migrate user configuration data when you upgrade from Singularity to Apptainer, so that it should feel seamless and you should have the same settings that you had before and same configurations for things like registry credentials and stuff like that when you have a fresh install of Apptainer that upgrades from a Singularity installation.
Great. Thank you very much. Have any other questions? So no one, I think Greg, you and I had talked about is talking about when is Apptainer going to be available in Apple?
So we should have invited Dr. Dave. Maybe in the future we'll invite Dr. Dave to our webinar. So Dr. Dave is a Fedora and Apple maintainer as well. So he actually maintains the package, both Singularity as well as Apptainer in Apple. So that is that is actually underway. I believe he was waiting for not the 1.0 release, but I think he was waiting for the 1.01, 1.02, something that just hammers out some of the bugs and really just guarantees, a certain level of what's the word I'm looking for? Stability and whatnot, just to demonstrate that, everything is working properly, everything's going good. Let it go through some initial testing in the community and whatnot. And then, basically release it into Apple. At that point, it is going to, I believe it is going to replace Singularity in Apple. So if you do a DNF or a yum install for Singularity, I believe it's actually going to install install Apptainer, and Apptainer will also upgrade Singularity.
Excellent. Oh, got one more question. So George asked again, is Apptainer completely compatible with Docker containers?
Completely is, I would say it's from a container perspective, yes. We are from an image perspective, we are actually leveraging the open containers implementation for downloading and managing the containers and putting them onto disk. So when you do something like a Singularity build from Docker and you put that into a Singularity container, it's using all those same bits that any OCI compatible runtime would use to pull from those registries. So from that perspective, yes, 100%. But then what we do is we do two things. We squash those layers down as we convert it to a CIF into just that single CIF layer. So that's the first thing that we do that's a little bit different. But also our runtime is a little bit different. So I would say it's not completely compatible, but it's really dang close. You can pretty much use any container that is in Docker Hub or any of your OCI based containers, and you can use them with Singularity 100%. Now, again, not everything's going to translate 100%. For example, if you need to, if your Docker container or your OCI container specifies that it needs to run as a particular user for that service, well, we're not going to support that. We always run as the user that's calling the application. So if I am GMK is my username and my UID is 501, I just dated myself, didn't I? 1001, and they changed that. So my user UID is 1001, and when I actually launch the container and I do a who am I or an ID, it's going to show that I'm the same user inside the container with the exact same groups, the exact same lineup, everything. So I didn't lose or gain any abilities from a credential kind of access perspective. But what I did do, what Singularity does do in Apptainer, is that it will block any privilege escalations from there. So I will no longer be able to get root once I'm inside that container. But little nuances like that, like we handle things a little bit differently, probably at least for an HPC or an application focused use case, you're not going to notice any sort of incompatibilities there. But if you're trying to run services with with Apptainer, you might see differences in terms of how they operate. But the container format, is close, but again, not exact. So hopefully that answers the question.
Very good. Thank you. Well, I want to thank you three for showing up to this webcast and also for the work that you've done with Apptainer. We really appreciate it. Thanks for spending the time with us, Cedric. I know it's probably later for you than it is for us. So thank you very much for joining. I also want to point out that we are hiring for Apptainer roles as well as other positions within our development team for CIQ. So go to our website. Plenty of opportunities to apply, and looking forward to hearing from you guys. So thank you very much, and we will see you again next week.
Closing thought.
Always.
All right. We've had a few more requests for Apptainer focused webinars. One of which around using CI systems to actually build and automatically manage your containers. So you can be doing CI and automatically building your Apptainer containers and making them available to HPC and application use cases. So we've gotten use cases like that. We've gotten use cases around how do we do encryption? How do we do cryptographic signing? Can we demonstrate some of this stuff? So we've gotten a number of additional webinar requests and demonstration requests. So definitely sign up. As Zane said, like and subscribe and keep track, because these additional use cases are coming, and I'm super looking forward to those.
Appreciate it. Thanks again for spending your time with us, and we will see you next